Hello, everyone. How is it going today? Just letting the rest of the team know that we are live in case we get any engineers in here to answer questions and help out. Well, hello to YouTube and Twitter. Hope we're doing well. Always like asking at the top of this, where's everyone tuning in from? And what brought you here? It's doing good? I'm doing well. Thank you for asking. Appreciate that. Yeah, we're going to be showing off a little bit of software factories today. A bit of a lightning stream, only 30 minutes, but we're going to run through some of the stuff that we've been cooking to help people deploy agents in a more automated way. So that seems at all interesting to you, then you've come to the right place. And if it doesn't, you'll be interested by the end of the stream, for sure. What's up, Shashi? Good to see you. And yes, I have not forgotten about that conference in October. I'm going to try to be there. I'll message you about it. Oklahoma, yeah. Fascinated by the software factory model. Well, perfect. We got a lot to talk about. We have someone named Hongi Chen. I don't recognize that name, but good to see you. Good to see you. Hongi has been at work for a little while. He'll be able to answer anything that I can't. Gleek from Oslo. Oslo, love that. Super cool. But yeah, I'm gonna do my best to do this whole thing justice. We got Safia in the audience. We cooked, so y'all can eat. Oh man, wow. Yes, we have. Yes, we have. We got a lot of warpers and a lot of fans out here. Martin from Moonster, love that. Yep, HYC. He's even got an acronym. He's so goated. Hello, Daniel. I think I've seen you around these streams a couple times. Good to see you again, if so. Yeah, well, now that we kind of have a good amount of people here, we can start talking about stuff. How about that? So it's a pretty simple agenda, really. My goal today is to show you what the agent platform is that we've set up. It's called Software Factories. I guess I can start with a simple poll in the chat. Give me a 1 if you have, Give me a 1 if you know what a software factory is, and a 2 if you don't really know. Like a 1 if you're confident, maybe we've set it up, maybe we're actively building one right now, and a 2 if you're like, I just don't know, but I'm curious to learn. We got a 1, all right. I'm expecting some power users today for sure. Okay, a decent amount of people have already been doing this, so that's cool. I will do some ground setting regardless, but it's good to know that we can actually dive a little bit into the details of how everything works. So if you're a 1, definitely ask questions as we go, because I can definitely speak to the underlying architecture of anything that I show on screen. Mostly people who are setting up factories in one way or another. I love that. Well, we'll at least do some definitions to make sure everyone knows how this stuff works. And the best resource for that is just going to be following resource that we already have on our own websites, which is, let me find this. Here we are. There we go. And I'll also share my screen. There we are. So if you're familiar with the software factory, you can chime in with your own sort of definitions on how you've been setting yours up. But in sort of the warp definition, this is what we've landed on. Most software factories land on a wheel like this. Ours are specifically these steps, where you're trying to automate the software development lifecycle, right? So you're starting from, I want to build a feature in our app. I want to add dark mode to our web UI, right? You would scope that out onto maybe like a conversation in Slack or Microsoft Teams. Maybe you would make a task on your task board, or maybe you would just prompt Claude directly and say, add dark mode, please. And then you would ping your teammates once you have a pull request. In all those cases, that's just intake, right? We're deciding what we want to build. And what we're working towards here is an idea of what if you could automate everything that happens from this to this. So you end up with a few steps along the chain, or agents really, that are powering each part of the chain. So the idea is you would put some ideas in the top of your factory, and then you would have an agent come along and look at that idea, or bug reports, or whatever you have described. And it would do a bit of recon first. So it would do research on your code base and figure out what would it take to actually ship this? Are there prior reports about this already? Maybe this is a duplicate of work someone else is doing. It can do all of that work to make sure that there's something unique that we need to go ahead and ship. And then it could give you a little bit a summary of what that work is to then decide what you want to do next. And that may be writing a spec if it's a larger feature that you want to implement. Maybe the agent goes off and does it right away. Like it does some research, it decides it has high confidence, and then you just code it straight to PR. And then you have the parts over here that actually make sure what is being created by those agents is something that's worth the human's time to review. So you want to have verification of some kind, probably with computer use, and I will show you what our computer use agent is capable of. There are many out there. But the idea is the agent should have the right testing suite to test its work end to end. It should also have some way to click around the app, so an actual sort of virtual environment with computer use. So it can click around the app, it can click through the menus and make sure that the UI appears in the right place. If it's designing something for the first time, it may actually see, oh, there's a problem with the layout. Let me fix that before I open the PR. Give it some way to actually have the eyes a human would before it pings someone for review. And then, of course, you have agents on the other side that would review the code, doing like code review. You may have seen CodeRabbit, Greptile, or Warp's own agent in that arena. You also want an agent over there. And then self-improvement. We'll touch on that a little bit today for sure, where you actually overview all the agents that are running week over week and decide how you can improve that process to cut down on token cost and improve the code quality. And that completes the loop, basically. So you throw in ideas, an agent does a bit of research, it implements and specs it out. It has verification tools to make sure that it's good before it pings you for review. And then there's some way to improve that system over time. Maybe it's a dashboard, maybe it's agents, or maybe it's all of those, which of course it is for something like Warp factories. So that's definition setting. And I've talked about this to death on many live streams, and we also have a number of resources that are useful there. This one is probably the best one if it's the one that I'm remembering. Yeah, the Guide for Engineering Leaders. So if you want deeper just definition setting on how all of this stuff works, this is a really good guide. But I'll just go ahead and jump over to our software factory solution. So the ones actually get what they came for, which is the meat and potatoes. How does this stuff work? So let me show you. I will hop over to the dashboard of a working agent to show you how this stuff actually connects together. So we actually have two of these that I can show you. One of them is what the DevX team is using right now to automate building all of our own internal apps and like market analysis and stuff like that. We also have a factory that's specifically for coding, and that's the one that we're putting a lot, so you can see a lot of inference through in order to build the Warp product. And we will shamelessly show you all the metrics right here. This is real. This is not some like dummy dashboard I've put together for demo purposes. This is like we stood up a factory to build all the factory infrastructure and the Warp terminal. All of it flows through this factory. So this is real. And you can see this is how, first off, like a bird's eye view of everything that is going on in that factory. So what I'm showing you right here is like the dashboard that you will land on once you stand up agents for each of those steps that I was talking about. And this is a portal that will help you stand up in order to do all of those things. By the way, I will put in the chat just for context. At any point, you can join this request access form, and we can actually like onboard you into this new tool that we have created. So if you have any interest in this at all, I would definitely suggest just like toss your email in there, and we can chat about it. But yeah, I'm going to go ahead and show you what we have cooked and what we have built. So this is it. This is the dashboard that you're dropped into once you deploy all the agents in the stack. And what is actually powering all of this? That's probably a pretty good question to jump into. So I can hop you over to the agents section. These are the automations that are spun up in order to build everything inside of the factory. So we have our foreman agent, which is kind of like the intake agent. So if you message on Slack, if you message you can actually message it directly from the web UI too. So in here, I could actually tell it, I want to go implement something. In fact, I could probably do that right here. I want to implement, I want to update the pin UI on the side. So the pin, and this is something I actually want to do, appears to the left of the chevron and doesn't introduce dead space on the right. It should appear on hover, something like that. So you can send this. Actually, I'll send it via Slack because that's normally how we do it. But we also have like an intake area where the foreman goes ahead and does everything. So that's what that is. And let me go ahead and actually kick it off because having something running in the background is a fun little idea here. So let me head over to the factory page right here. At Wilson, I want to do this. There we are. So yeah, I can actually show you right here. This agent is running right now. So I will open a new window for this. So this is actually it. We've set up, when you create a factory using Warp, we stand up those agents that I showed you. So the triage and the spec and the review stuff. And then we also give you a Slack connector. So if you want to put stuff into the top of that funnel, you can just tag your factory. And you can have multiple as well. So you can name the factory whatever you want. It's not just like Claude, and Claude does everything. No, you can define factories for different teams with different access and security permissions so that you can decide what they are able to work on. And then the agent's just able to go off and do things. And we'll check back on it in a bit. But yeah. That's a little bit more about the factory. We have agents, we have an intake, and we have connectors and triggers to put things into the top of the funnel. So Slack is one of them. Just directly running the agent is another one. And I've actually spoken to the team. We're improving the quality of this new run page to be super high quality as well. So get ready for that. We also have intake from Slack. We have intake from GitHub issues. We have intake from any surface area that you may want to use. And then once things start running, you can actually see the activity of that stuff over time. So you can actually see right here, there's an agent currently in the triage phase of implementation that started on a Slack thread. And we can look at it if we want to. So if I wanted to see what this agent is doing, I could hop into the agent conversation. And this is the underlying agent behind the scenes. So this is a Cloud Runner that stood up. So this is both self-hostable and also something that Warp can host for you. And it will pass in all the information about what is coming in. It gives it whatever metadata, if it's like a reply or something like that, and it needs to follow up. And it will also pass off whatever skills you have defined in your factory so that the agent's able to do quality work. So for example, we have a skill specifically for looking at Slack mentions. And it will use that to understand, oh, I use the Slack MCP. I can read the thread for full context. And then I can start looking through all the repositories in this cloud sandbox to start implementing something for me. So yeah, that is the basis of it. We have a cloud sandbox backing this. They're triggered by whatever input that you want. And they're backed by skills that you can configure. And that kind of takes me to the next part of the factory. And by the way, I will be checking for questions in a second. I just want to make sure we get the lay of the land here. So we have an agent running. It's doing all this stuff. And if you're wondering, how do you configure the environment and what it has access to? Well, all of that lives inside of the agent configuration over here. So this is the overview that I just showed you. The foreman handed off to the triage agent in order to start researching everything. And if we click into the triage agent, we can see all the tools and stuff that it has. So first off, we see the MCPs. It has Grafana for error monitoring, our own debugger, and Figma if it needs to look at a mockup that we linked inside of like a Slack thread or something. And you can connect whatever else you want. Then we have some secrets that are based on just the way that our workspace works, as you would expect. We have our harness. So this is actually changeable, by the way. You can change it to Claude Code or Codex. But here we're using Warp's own harness. You think of it like an open code if you haven't used it before, but better. And then we have our model selection. So you can select whatever model you want. We've decided Grok 4.5 is good for research tasks because it's very token efficient. That's kind of the beauty of using like an open harness that has whatever model you want, is you can decide, I want to use one model provider for triage and one model provider for implementation, for example. Like maybe you prefer to use Sol writes code, but you want to save money on the research phase. So you switch off models in that sense. We also have open weight models too, if you were curious. And then down here is the agent props. This is actually what defines your triage agent and how it behaves. And this is just a skill. So it's actually referencing out to other skills that are available to that agent. And all of this is manageable either through the portal itself or on GitHub if you prefer to check it in as code. That's what we've been doing right now. So everything that I'm showing you here is actually something that's agent managed. So it's not a private portal where all this stuff is getting thrown together with custom object syntax. It's just Markdown. So every agent is configured as a Markdown file, including triage, for example. So this defined the triage agent with an agent.md. We also have all those other skills I was showing you. So we saw it had access to a Slack skill. That Slack skill is defined inside of this repository. So we can actually see this is the Slack skill and how it knows what tools are available from the MCP server. Very cool. We also have a skill for linear. So if you wanted to intake from linear instead, you can totally do that. So here it's looking at reading the issue, searching, and some ways that may define like your labeling system. So here we use Warpy Factory because Warpy is kind of the code name that we've been using for a while, and we kept it around. So we customized the labeling system. You can do whatever you want inside of here, of course. So if you have a different way of working with your task board, you can define that inside of here. And it's all just scaffolded in this way. It's also fun to look at the factory.yaml. This is like the overarching file that indexes all of the other config. So this is defining the entire factory itself. We have the repositories, the owners for each of those repositories, the secrets available to all of the agents, and you can, well, I should rephrase that. These are all the secrets that are available in the factory, and then you can define granularly which secrets bubble down to which agents. It's basically how it works. And then you have all the MCPs available, and again, you can manually connect the servers to the agents, decide what they have access to. And then you have other configuration that you may need to define, like defaults whenever you create new agents, if you do. And it's all checked in as code. So you can tweak it yourself and version it if you want to make changes over time. If you want to update the config with a pull request, you can, of course, use the pull request system. And it also means the agent itself could update the factory configuration. If something is outside of its capabilities, the agent could decide, I need to open a PR on the factory itself, if you don't mind taking a look. So the agent can like expand its environment programmatically, which is kind of cool. So I'll pause there since I've introduced a lot of things here. Configuring factories as code, triggering from Slack, multiple agents for each step of the chain, dashboard. So here it's actually doing some work as well. The dashboard that actually shows you an overview of what the agents are doing, and the runs page, which actually shows you all the agent runs that have happened. Activity is a nicer view on top of those runs. Yeah, let me stop here and just make sure of any questions that we might have. Not using the warp terminal. Yeah, so the idea is that you might pull down the warp terminal to do certain things that require your attention. Like if you wanted to pull down a conversation and work on a spec with the agent interactively, you may actually pull it down into warp. Another place you might end up seeing warp is here. So this is the session that's driving our Slack conversation. And this is actually the warp terminal compiled for the web. Crazy, but this is actually like the fully fledged warp terminal. And we're just using it as our generic interface to see whatever's going on inside of that box, to see whatever the agent is doing. So in many ways, you are using the warp terminal. You might be using it to like work with the agent if something went wrong, or you want to sort of steer it in a certain direction, or it might be interacting with it just in the web version, which is what I'm showing you right here. Submitted a PR to warp terminal and got to see that process. Is that what's running the factory? That's a great question. So the factory that's driving our open source repository is not quite on this system yet. It's using what I would call like an earlier low fidelity version of the system. So if you've ever interacted with the warp repository, you may have actually seen our agent hop in to help you with issues. And we use a labeling system for each step of the chain. So you actually see inside of here, like if something is moving on from triage to implementation, we apply GitHub labels to do that sort of thing. So we can take a look here at anything that was marked ready to implement. And if we drill into it, we can see here's what the triage agent did. So the same thing that I just showed you in Slack is actually running on our GitHub as well. And this agent triaged the issue, looked for duplicates, and summarized what it would take. And then a maintainer marked it ready to implement, and then another agent started implementing and working on a fix. So it's very similar to the factory dashboard that I was showing you. But it's, in this case, I think it's driven by just like custom workers. And we honestly don't have all the tooling that I'm showing you here. So we don't have our dashboard and activity set up to monitor warp itself, but we're going to. We just haven't set it up. This was shipped a couple days ago, and we've been trying to dog food it against our own projects first, and then expand it to the full open source community second. So yes, what Warp Factories gives you is not just like the infrastructure. We're also giving you like the dashboard, the configuration files, the agents, so that you can kind of have a packaged up version of all of this. Robert asking, what's the purpose of this? Good question. I mean, the purpose of all this is really, it's hard to manage all of your agents, especially in a team context. The reason that we built it is, I mean, we've noticed this ourselves. We've talked to a lot of people who are experiencing the same thing, where everyone's using their own agents and their own MCP setups on their computers at a company, you know, like on a team context. And it's hard to tell, first off, what are the costs across everyone's little agent tools? Like, how much is Jim spending on his Codex subscription? How much is John spending driving things to Claude Fable? There's not really a central dashboard for where all this stuff lives. And there's also not like a sort of agreement on what agents are we going to use to implement everything. Everyone has their own tooling. They have their own security permissions and MCP access. And it's just hard to manage as you scale up and say, all right, 100 or 200 developers are going to be doing this right now. And you'd be surprised at scale how hard that problem can be. So this is really trying to help out with, we want to know, what are our PRs costing us? And how can we improve the cost per PR over time? That's one big thing that we give you, is like metric monitoring. Like, if you drive all of the stuff through this automation system, instead of doing individual Claude Code instances on everyone's computers, we can get a better sense of where all the PR costs go. So that's a big thing, is like, everyone's using different tooling. Let's centralize. Let's agree on the models that we want to use. And let's actually try to drive the cost down by improving our skills and improving everything else about it. So that's a big driver. Another one is, when you centralize, we have a way to actually like improve that system and score the quality of that system, which kind of takes me to these tabs. These are honestly my favorite tabs of all of this. So we have scores and self-improvement, and they're very related. This is the idea that now that we're driving all of these PRs through these like cloud sandboxes, and everyone's using the same models for this, we can actually do some inference. We can look at all the conversations, right? All the conversation data is flowing into this factory. So why not have an agent look at all the conversations that we're having as a team week over week and decide, oh, it looks like every time we ask it to test the desktop app, it messes up on a tool call. And we don't notice it when we're just using our own agents. But looking through the conversation traces, yeah, the agent messes up on the tool calls every time it tries to run the desktop app. Let's go ahead and suggest an improvement for that. So the two components to monitor that are first the scorer and then the improvement agent. So first, the scorer. These are agents that look through your conversations every week and grade it on criteria that you set. And right now we're trying out a ton of different strategies for this to find the best scoring algorithms. But the ones that we found early success with are efficiency and code quality. So we're testing out a bunch of different models to see which model performs best at these tasks. But if I click into it, it's pretty simple. We want to have an agent that grades the efficiency of all of the agents that run in the system. And it has a rubric. So it decides how it's going to evaluate the cost of reaching a result. You can decide classifications. You can decide pass and fail thresholds. You can get really granular at actually like benchmarking the system and seeing, is it efficient or not? And how could you improve the efficiency over time? So that's what the scorers do. Their goal is to benchmark and judge the quality of what all the agent conversations are doing. That's all they do. And then we have a second agent that looks at all those scores. It looks at, okay, the efficiency rating was like a 56 out of 100. Pretty good, we could do better. So the agent looks at that score, it looks at all your skills and all the stuff in your repository, and it decides what can we improve about this system. And it's able to open PRs to decide how it might improve that system. I'll confess I actually haven't looked at these recently, but we'll go ahead and take a look. So this is one suggestion that it made based on the performance of all of our conversations over time. So here it's looking at a GitHub skill. Let me actually read it. I have not read this before. But we have here a self-improvement run on this. 7 minutes after branching. It then ran the skills prescribed verification, received that, and reported success without mentioning it. The base rule governed branching only. And the recipe showed no base, so nothing carried to confirm. OK, so it's messing up on some calls to the GitHub CLI, from what I can kind of tell. I may be getting this wrong as I glance through it. Verification bullet asked for this, but named it incorrectly. OK, interesting. So look through the conversations, and it found this. And it has some evidence across 2 runs in our past. Cool. And you can fine-tune it to say you have to see evidence across a number of runs instead of just 2. You can do it however you would like. These are really primitives in order to judge your system. But here it's actually saying this is how we should improve our PR description skill so it actually gets a better result. And it reduced the wordiness. Crazy. Usually they add more words. Here it actually reduced it. It also noticed that this sample right here doesn't include the base branch. So let's go ahead and add it so the agent doesn't mess up next time. Pretty cool. This is something that I wouldn't even catch if I was looking at my own stuff. So now we have an agent that's looking through and figuring out how can you improve that system over time. That's the value, really. First off, it's all the monitoring stuff to see what your cost to PR is. And then it's actually suggesting changes to improve your cost to PR. So let's get this cost down. Let's get the code quality up. Let's reduce the amount of back and forths that we have to do in the code review process. That's what you get when you put sort of a factory dashboard on top of everything. So that's what we're playing with right now. And what is the control plane behind the scenes? I'm curious if you have sort of like more granular questions about that. I've kind of answered it at a high level, hopefully, where we have hosted runners for each of our agents, right? And then we also have a hosted service that lets you see a dashboard that aggregates all of those agent runs. That's really what it is. And the control plane itself, which is actually what we're looking at here, is platform.staging.work.dev. Or actually, I'm realizing if you mean control plane as in like agent orchestration, like agents spinning off other agents, that is guided by the warp harness or whatever harness you're using. So this is kind of how you define the control flow, I guess you could say. And it's really handing off between agents in an assembly line is how I would look at it. So you have a foreman agent that looks at whatever's coming in. It hands off to a triage agent that does some research. It might hand off to either spec or implementation. Really, it's going to be the foreman that decides is how it works. So the foreman does a bit of triage. Then the triage agent reports back to the foreman. Here's what it is. The foreman decides whether to implement or spec, and then those hand it back up to the main conversation lever. And that's kind of how it works. And each of these is free to stand up sub-agents in order to accomplish a task. I can actually show you inside of here that we have a few agent runs that included orchestration. You can expand the bubble here to see this one actually spun up a subtask to do some research before it went back to the main agent. So all of this is driven by a orchestration-ready harness to do all that sort of stuff. Another thing I can call out is by putting this stuff in the cloud, you give it computer use access, which is pretty cool. You don't have to move everything to a factory to have this feature, but it is a nice side effect. So here is an agent clicking around its own work. And because it's given a cloud runner in order to do all of its work instead of your computer, it's free to just click around whatever it built. Like it's not going to bother you. It's not going to hijack your cursor. It can just test its work and then give you a video that actually shows you, here's me clicking around. Here's all the keyboard inputs that I did. So when you're reviewing the PR, it's not just, is the code right? It's also, did it even build the right thing? You can easily tell from the video, like, oh, the agent was on the right track or it was on the wrong track. So that's the beauty of having something like that. How customizable is it, generally speaking? The answer is very customizable. Very customizable. In fact, this is one thing that I meant to do at the top of the stream. I'll just go ahead and do it now. So this is what the setup flow looks like to create a factory for the first time. And this should give you a sense of all the stuff that you have available. So if I wanted to, maybe I should go to platform.warp.dev, actually. This is our production environment. So I'm going to go create a new repo. And I'm going to connect whatever repositories I want. So here I'm going to connect to an organization. You can add as many repos as you want to your environments. So here I'm just going to add Unleash, which is one of our setups. And maybe I also add our factory configuration for it. Add those in. You can name it whatever you would like. This is going to be how you tag it from Linear, Slack, wherever. You can set a profile picture to find it later. You can connect it to whatever you want. I can set it up later. And then this is the customizable bit. So these are like the pre-built agents, but you can add any agent that you want. So you can actually configure, I'm going to create an agent that runs, or I have an agent description that decides, let me actually think of a custom agent that you may want. Maybe you want an automation that like does architecture review once a week. You could add an agent for that in here. That's like the architect. So that would be like a sixth agent or a fifth agent that the foreman has access to. These are just like the opinionated starters that you may have, like having it do triage spec code review. But if you want to add more that the foreman has access to, it's almost like how you can add skills that the agent has in its tool belt. You can add custom agents that the foreman has under its belt. It's kind of like sub-agents, but very, very opinionated, or sorry, very capable. And yeah, then you can set up your agent config, and it lives as a GitHub repository too. So you can configure the infrastructure as code. Then you can connect your issue trackers, hit finish, and boom. So here we have our factory standing up. I was zoomed in a bit too much. And yeah, there we go. So this is actually the tester flow if we want to, but I'm going to go ahead and skip that for now since I think we've done it enough. And there you go. There's your agent set up. And right down here, this is what I was mentioning. You can create a new agent and customize everything that's available to it. You just need to describe what the agent does, like architecture review. You can add your MCP connectors, which is whatever you set up in your environment. You can set your harness. So you have other harnesses available. We would love to add more and more to this tool chain. We just started with the basics, which is the warp harness with every model, Claude Code or Codex if you want those specific harnesses and models. And then you can set whatever model you want if you're using warp. So this is like the generic inference where you just want to pay token cost. You don't want anything fancy, and you want to route it to whatever. So maybe I want to use Kimi for this. The runner can be the default Linux box that we give you, or you can self-host it. So that's customizable. And oh, that's actually it right here. So we set up a number of test hosts, or you can use Warp's own hosting if you just want to save a bit of time. So you can do weekly architecture review. Let me actually use voice. Do weekly architecture review across the Unleash repository and propose changes in a pull request. This will run as an automation, and it'll be available to the factory foreman to call if it's useful. Right? So we'll throw that in. And then you can also add some automations if you want to. Oh, I'll also throw that up here. And then we can hit save, and now we have a new agent configured inside of here. Right now, I'm using the non-GitHub version where I can just do it all through the web UI, but there's also an option to host all of this through GitHub if you would prefer. And then in the automations tab, this is where you can set up triggers to run on like a cron schedule or something like that. These are triggers that are already set up by us for GitHub issues. So if you ever file a GitHub issue, it could wake up an agent. But you can create a new automation. You can decide which agent to kick off, maybe our architecture review. You can add trigger, which might be a Slack mention or schedule. I said weekly, right? So we're going to run it weekly on Mondays, architecture review. And we don't really need an extra prompt. So now we just have an automation set up. Instead of using a trigger, now we're using like a cron schedule to run this automation. And this will flow into our dashboard whenever that weekly architecture review occurs. Our scoring agents could actually review the quality of that architecture review. So I could look at this and say, I want to score the quality of the architecture review. So I could say like architecture quality, right? And I could say in the instructions, I want you to look at the architecture reviews that are opened as pull request, and I want you to evaluate whether architecture changes are accepted or if they require intense changes. We should be judging on whether it is accepted versus whether it requires fundamental tweaks. I would fill this out much more thoroughly, of course, but I hope you're getting the idea of like, you can just build these automated systems very quickly and easily for all of this stuff. And you can judge it with Kimi 2.7, which is a very lightweight model for this sort of thing. You can set up classifications, which I honestly haven't done before, but you could if you wanted to. Let me actually see what that would be. So if I wanted to set it up for adequate test coverage, PR quality. Yeah, sure. Architecture are accepted with minimal maintainer input. And the classification score could be whatever you want. It's very technical. And I believe that would be everything that you need. You can also set this up to analyze failing runs if you want to. I'm missing something. Oh, shoot. I keep messing that up, but that's clickable. So now we have an architecture review agent. Oh, shoot. What did I mess up? At least one label score must be... Oh, gosh. I've never set one of these up before. I may actually have an agent set this up for me, honestly. And that is something else we have, by the way. There's an MCP server to have an agent configure to factory for you. I would show it, but we're already over time. So I don't want this to go over too much. But let me go ahead and see if there's any final questions to answer inside of this. Hopefully that answered the customizability. Okay, and also Robert was just checking this out on his lunch break. Hopefully this was useful. Taking a break from my company, making me use Copilot in a way that maybe we shouldn't. Yeah, I understand, man. It is painful out there. We like to think that this is kind of the North Star that we're all trying to build to, but it starts from holding Copilot the wrong way. I think that's the rite of passage to get here. Is the factory code stored in a repo you select or a separate repo? It can be either. You can store it inside of whatever the project is. So if you wanted to store it inside of, let me pull it up for you. I believe it would be Unleash. If you want to store it inside of the like mono repo itself where all the code lives, you could do that. Or you could put it inside of a separate repo, which is generally what we do and kind of what we would recommend. So this is the factory config. So here it's actually setting up agents, automations, runner scores. So everything that I was showing you in that dashboard, it's in here. So we can see all of these. And this is a separate thing, by the way, separate from what I was showing you in the panel. But this is like if you export everything to be managed in GitHub, you can do that. Right now, it's like a one-time operation where you can either manage it all through the web UI or you can manage it all through GitHub commits. You choose. So here is how you would do it in like a GitHub managed context. And this is good if you want to like check it in with Git commits, you want SOC 2 compliance. Like it is useful to use your own code forge for this sort of thing. But you also have the option of just not using that and using the GUI for everything. And I believe we check it in as code as well, just not with GitHub, just with a more streamlined tool in order to do that. What are Warp Factory's key features? Well, I don't want to annoy everyone who's been looking at the stream all the way through this, but high level. Warp Factories are the way to automate the software development lifecycle. So we give you a place to manage all of your agents across triage, implementation, review, and improvement over time. We give you cloud infrastructure to run your agents in a central place so you can manage all of your secrets together. We also give you a dashboard to monitor cost over time. So let me hop back over to our real dashboard for this. Platform.staging.warp.dev. We give you a platform for this to see the cost per PR, task compliance, etc. So we look at all those conversations happening in those runners. We give you some inference. We give you a framework for standing up agents at each step and automations to run those agents from any trigger. So Slack, Linear, GitHub, whatever you were going to set up yourself, we'll just set it up for you. You can run everything and see it with computer use. So our harness gives you all the tools that you would need. Here an agent's actually looking at its work and making sure that it works. And then we give you self-improvement So it can actually look at all the conversations you had and decide ways that you can improve your skills so that the agent performs better next time. Speed run. Hopefully that was useful. How are PR conflicts handled in general? The same way they always have been on GitHub. We don't do anything different with the source control. So same way that you've always done it. I don't really think there's anything different. Pricing models for use. So it's in early access right now. The agents are going to run at token cost. So you can bring your own harness and your own like Anthropic or OpenAI keys, or you can drive inference through us if you want to use open source models, which will probably be cheaper. And then there's a little bit of compute cost, but it's pretty negligible. Just think of it as a place where your company's already paying token cost, and now you just want to automate how the agents are deployed. That is what we help you do. Since the last few months, we're working on a harness router for the optimization part. Where does harness optimization come in place? So it is as part of this factory system, I guess at a high level, that's where. So the same place that you are, if you're running the agents through this system, right? So it is assuming, yes, you are running your cloud agents through this system. I think it's a great system to run them through. But if you are, then the self-improvement agent hops in and looks at all those conversations that are had inside of here. The one thing that we have heard from people is like, we've set up our harness the way we like it, but we haven't set up all the rest of the stuff. Can you help us with that? Like, let us bring our own harness, but everything else, give it to me. That is something I'm hearing enough that maybe it's a feature we want to add. Like I've already shown you inside of the agent panel that there is a way. Oh, shoot. Let me go to one that's not GitHub managed to make this a little bit easier. Inside of here, you can change the harness that's running inside of this sandbox. It doesn't really matter what the harness is. There could be a way to introduce custom harnesses and things like that. So if you already have a system for like the orchestration piece, you could maybe slot it into here and just use Warp for the monitoring and self-improvement pieces. Could be interesting. If that sounds interesting, get on the wait list, baby. Get on the request access list. I will definitely make sure, like, we've seen you around. We'll make sure that you get to try this thing. A lot of components are swappable. Yes, indeed. Is the sandbox swappable? Yes. So it is a self-hosted sandbox. The default one is going to be a Docker container using Linux, so the most basic vanilla setup that you can imagine. All the environments are set up with Docker containers. At this point, it's pretty hands-off. Like once you add your code repositories, we figure out what Docker image would work best for those code repositories. But you can customize it however you would like. And you can also host it on your own runners if you prefer. I think our only requirement is it needs to be a Docker-compatible container that you set up. So if you're using different container setups, we'd love to hear how you're setting it up. Maybe we can help you. But Docker is kind of the main way to do all this stuff. I guess we're just going over, by the way. I do need to go in a few minutes, but might as well answer questions, right? Have you observed context loss or bloat since all the stations are running fresh sessions? Oh, yeah, it's a good question. So the idea that all of these agents are running in their own sort of isolated context layers, it can result in bloat. It can, because you need to pass context from one to the next to the next. And we're working on this. So there is the trade-off between optimizing the models used at each step versus the context bloat that you get from that handoff. Like here we're using Grok for the triage step, but we're using a different model for the implementation step. Yeah, right now we're actually using one of our auto routers for that. So the good is that we're using a very token efficient model for a lighter weight part of the process. So we're not using a heavy agent for research. We're using a lightweight agent for research that hands off to a heavyweight agent. But that also means that you need to hand off context between them in order for that flow to work. We haven't, well, I would honestly want to talk to the quality team to understand like what we're trying to improve there. My answer would be there's always going to be bloat in the process, and we're just working on benchmarking tools in order to make sure that that gets minimized so that the trade-off of using more efficient models for each step outweighs the added context of handing off. And we think, at least from early testing, that's the direction we're going to go in. So that's what we're building towards. Yeah, so I think I've hit all the main features of this guy. If there's any last minute questions, definitely let me know. Otherwise, I will sort of throw on the screen a call to action for anyone who's found this interesting. So we have an access form that you can see right here. Right now, we're doing it early access because, frankly, this is early technology. This is early software. So we want to work with people who are already exploring this space to feel out what the features need to be. We want to fine-tune ideas like self-improvement and scoring by testing it with real companies. Because we've tested against our own workflows and a few partners already, but we want to expand that pool before we go general access. So if that's you, if you'd be interested in this, then definitely join us, all right? You can get early access to these tools. Everything that I showed you, set it up on your own system, and we'll be able to help you in every step of the way. We got our engineers manning the phones right now to help everyone do it. Well, Nathan, get in here. Get in here. We would love to have you trying it out. Yeah, so with that, that's the main CTA. Just go ahead and check out the access. And also, if you want a recap of everything here, or you want to send some information to someone because you're curious to get other people's opinions, we have a video filmed by yours truly that walks through all of these features in a more succinct guide. So this is like an 8-minute run through of all the features that I showed you. And there will be more to come. Definitely shorter things as well if you want something that's a little bit more bite-sized. I believe actually we have a blog post as well. So if you want to have something legible that you can point an agent at, we also have something on our blog that describes that everything in that video, but in written form. So yeah, that's everything that I wanted to talk about. I hope you found this useful, and I will see y'all potentially on the next stream. We're going to be having a few more of these just to talk through the way that software factories work. So take care. Thanks for joining me.